Alright, so in this video we are going to be reviewing Charles's Law, and you just watched the demonstration with the balloon. And what we noticed with that balloon is that every time the temperature increased, so they boil the water in the balloon, the volume of the balloon also increased, so it got really tight inside that beaker. And then also, after that, they put it into an ice bath. So then they decreased the temperature, which meant that the balloon was going to get smaller, and we did witness that. So the volume also decreased. Now, because the temperature and volume follow suit with each other, they have what we call a direct relationship. Okay, so that means anytime one of those variables goes up, either temperature or volume, the other one goes down. Also remember here that pressure and the amount of gas, so P and N, those are going to remain constant when we are dealing with Charles's Law. A little bit of review about the formula that we can use in order to calculate Charles's Law. We should always be using V1 over T1 equals V2 over T2. So if we have a change in temperatures similar to that demo, we can calculate one of the volumes as long as we have one of the other volume. So let's say we have the volume of our initial balloon, we have the temperature of the balloon initially, and then we change the temperature. We would be able to find that final volume of the balloon. Things to keep in mind here is temperature has to be in a certain temperature scale. So if you guys remember from our discussions, 0 Kelvin, looks like okay, but that's 0 Kelvin, is absolute zero, meaning that we cannot get any lower than a 0 in the Kelvin scale. So we always want to convert our temperatures, which are usually in degrees Celsius, we want to convert those to the Kelvin scale so we do not get any negative values and therefore negative volumes maybe sometimes, which is impossible. So let's take a look at how to calculate using Charles's Law. So I'll leave that plot there for us to see. Here is a problem. Okay, it says a sample of oxygen gas has a volume of 3.3 liters with an initial temperature of 27 degrees Celsius. If the temperature decreases to 12 degrees Celsius, what is the new volume? So the first thing I want to do is I want to make sure that this is actually a Charles's Law problem. So I'm going to identify all of the variables. Well, this first thing here says, okay, we have a sample of gas. It's a gas, so we know that we can use our gas law. And it says it has a volume of 3.3 liters. So I'm just going to go ahead and under that and put V1. We're going to say that's our initial volume. And then it also says with an initial temperature of 27 degrees Celsius. So there is my T1. So I've got a V1 and a T1. If the temperature decreases to 12 degrees, well, so that I know if this was my initial temperature, now we've dropped down to 12 degrees, so that's going to be my T2. What is the new volume? So it's asking for us to solve for V2. What is the new volume? Okay, so we've identified all of our variables, and now we want to actually plug those in to this equation up here. The V1 over T1 equals V2 over T2. So I'm just going to rewrite that here. Okay. Scooch that up now that we have the equation written again. And let's go ahead and plug that in. So our V1 we said was 3.3 liters. And our T1 is 27 degrees Celsius. Now, can I keep it at degrees Celsius? No, we need to convert this to Kelvin. So in order to get from degrees Celsius to Kelvin, we want to add the number 273 to our degrees Celsius. So let's go ahead and do that. Get my calculator out here for you. So if we have 27 degrees plus 273. That means that this temperature in Kelvin is 300. And we might as well just go ahead and do our T2 also. So 12 plus 273. That means our final temperature here was 285 Kelvin. Okay. All right, so now we can plug those temperatures in. So 3.3 liters was our initial volume, our V1. Our T1 is now 300 Kelvin. And that we're going to set equal to our V2, which we do not know, so we're just going to keep that as a V2. And our T2, we just converted to Kelvin, is 285 Kelvin. Now, if you notice here, we have set up a relationship here that's ratio. So we want to make sure that we cross multiply in order to get these out of a fraction. Just a whole lot easier to work with if we're just dealing with multiplication. So if we cross multiply here, we get V2 times 300 Kelvin equals 285 times 3.3. Okay, so we've got this set up. Remember, we're trying to solve for our second volume here. So what do we need to do in order to get volume by itself? Well, it looks like we need to divide by 300 Kelvin on both sides of the equation. So now we have V2 is equal to 285 Kelvin times 3.3 liters divided by 300 Kelvin. Let's go ahead and type this into our calculator. So we've got 285 times 3.3 divided by 300. You can do it all in one step, just like that. And our answer comes out to 3.135. We can only use 2 sig figs because of this volume here, so we need to round that to 2 sig figs, which would be 3.1. And then because we're dealing with volume and our initial volume was in liters, our final volume would also come out into liters. And that is how you use the equation for Charles's law to determine an unknown volume or temperature if you have the other three. Thank you.